Hi, my name is Bradley Jang, student number V00876678, and this is my video for the third assignment for CSC 361. Before we get to my actual code and video demonstrating the code, I want to talk a bit about my methodology. Specifically, I want to discuss how I have done my sequence number and acknowledgement numbers. For this assignment, I have decided to do it such that the sequence number is incremented whenever the client sends a package to the server. Conversely, the acknowledgement number is incremented whenever the server sends a packet to the client. You can see this in the attached picture. The client sends a SYN packet to the server. Here the sequence and acknowledgement numbers are both 0. The server then responds with an acknowledgement packet. Here the acknowledgement number increments by 1. The client then receives that packet and sends another ACK to the server as part of the three-way handshake. Here the sequence number is equivalent to the acknowledgement number plus 1, meaning that the sequence number is 2, as the previous acknowledgement number was 1. 1 plus 1 is 2. You can see from the narration and the attached picture how my numbering system works. Now that our introduction is over with, let's walk through the code. The first file we'll talk about is server.py. The first thing we do in this file is create a UDP socket. The code to do this is fairly straightforward and is basically the same as what was done in assignment 2. The next thing we do is receive a SYN packet from the client. This is part of the three-way handshake. You can see that we instantiate two variables, SYN message and address, and assign values to them based on the data we receive from the client side. We split the SYN message using the pound symbol as a delimiter. We will see more of this in the client side, which we will talk about later. So after splitting the SYN message, we'd assign its values to several values, as you can see. These include packet type, sequence number, acknowledgement number, payload length, and payload info. After that, we send an ACK packet back to the client. Here we only change the values that are necessary. So we change the packet type to ACK and increase the acknowledgement number, as was mentioned in the introduction. The other values do not change. We add all the values into a message, separate them once again using the pound delimiter, and send them back to the client. Now, let's move on again. After sending the ACK packet to the client, the server should get two packets back in return. These are the ACK message and the GET message. What we do with these messages is fairly similar to what I described just now. We receive them, split up their components using a delimiter, and assign them to several different variables. The variables are constantly being updated. For instance, after the GET packet is received, the variable values from the ACK packet are updated with those from the GET packet. Now that we have the GET packet, we can actually start sending data. We take the payload info from the GET packet and assign it to a variable, file to read. We then open the file signified from the variable. Then we enter a while loop. We read from the file and create new packet data based on the file data and its length. We then get ready to send this data. If the length of the file data is 0, we know that we have read the file in full. We can thus send a FIN packet to the client, using the same conventions as all the other packets we have sent. Packet type is set to FIN this time, and so on. Otherwise, if the packet length is not 0, we send a data packet. I will show you this momentarily. Now, we're back in the while loop we were showing in the previous picture. You can see the else case, which is what we reach if the payload length is not equal to 0. Here we send the data packet to the client and await an ACK reply. As specified in the parameters for this assignment, after receiving a data packet, the client sends an ACK packet back to the server. That aforementioned ACK packet is what we are receiving. After receiving this ACK packet, we loop back to the top of the while loop and continue reading from the file. Now, that is all the code for server.py. Let's move on to client.py. Now, let's go through the code for client.py. Just like we do with server.py, the first thing we do is create a socket. Fairly straightforward. Now, note that we have a variable, document to retrieve, with sys.argv3 assigned to it. When we run the client program, we enter the document we want opened as the third argument. So we save the name of the document to this variable. Then we create a SYN packet. We already discussed packet creation and sending earlier, so there's not much more to discuss with this section. The SYN packet, once again, is the part of the three-way handshake, which we discussed in the previous part. Moving right along. Now, we once again have two more packets that we create and receive. These are the ACK packet and the subsequent GET packet. On the server side, we saw the server receive these in the code for server.py. Again, the creation and sending is fairly straightforward. Now, the client is ready to receive data. We open the file that we want to write to, output file.html. Then we move into the while loop. Now we have the big while loop. You can see that we have a try except block. This allows us to implement the socket timeout. If we do not receive a packet from the server within a certain amount of time, the client returns an error message, the timeout message, and sends an error packet to the server side. This lets the server know that the packet was lost and allows the server to keep transmitting. It is likely that you can do the timeout without the error packet, however, I could not figure out how to do so. Now let's look in the try block. You can see that we receive a data packet from the server and split it into its component parts using a delimiter. This is similar to what we've done with other packets. We then check the length of the payload. If the length of the payload is 0, we know that we have received a fin packet. This means that there is no more data to be sent, so we can close the output file and escape the while loop. Otherwise, there is more data to be read. In that case, we write the information contained in the payload, that is to say the data from the file, into the output file. We do this using outputFile.write. We also create an acknowledgement packet and send it back to the server. We then loop to the top of the while loop so we can continue receiving information from the server.